Is 404 log functions. And so we're looking for what exponent 5 needs to get raised to get to 125. So the exponential expression would be 5 to what power is 125. And this is the basis for logs. 3 is the answer. So being able to represent exponents in log form is the basis for this whole unit. And if you can understand this page, you should be able to understand the rest of the unit, hopefully. -3, right? Because that would flip it over and cube it. So why don't you take a minute and answer 1 through 18. And if no base is given, you're going to use 10 as the base because those are called the common log. So quickly go through and evaluate up through 18, and then we'll put the answers up. The hardest one on here was number 5, but we got -3 and then 1/2 because that's the square root. 4 cubed is 64. So this one, I knew that they both had to have a base of 3, right? So how can I get 27 down to a base of 3? I take the cube root of 27, so that's the 1/3. And then how do I go from 3 to 9? I square it. So the base here is telling me to take the cube root of 27, and then the 2 here is telling me to square the result to get to 9. So that would be kind of the hardest one. This is 10 squared is 100, so common log, they do not write the base of 10. 3 to the first is 3, 5 squared is 25, that one was easy. 2 to the fourth, -1st is the 1/11th, right? 3 to the fourth was 81. This one, did I count that right? 2 to the 7th is 128. Is that what you got? 2 to the 6th, I think, is 64. So 2 raised to the 7th is 128. This again, right, same as number 6. This is the 1/2 power. We're going from 25 down to 5, -2, 0, and -2. So we got those? Okay, so here is what I wanted to make sure you had. Log functions are the inverse of exponential functions. A logarithm is just an exponent. So another place that we see this is with addition, subtraction, multiplication, or division, right? Don't we say that like when we're doing x plus 4 or x minus 4, those are opposites of each other? Can't we think of subtraction as adding a negative number? Just like we can think of division as multiplying by a fraction, right? So a log, we can just think of as another way of writing an exponential function. And these are going to be the inverses of each other. So then on your first assignment, it's going to have you practice going between log and exponential form, which is really important for what we're going to be doing next, solving application problems. Refocusing every time. How about that? So this is to rewrite in exponential form. So 2 to what power is 64? So they want you to sit in the habit of writing it out as an exponential function. So we know that 2 to the 6th is 64. And then you're going to do up through number 4. And then 5, 6, and 7, they want you to rewrite it as a log. So in number 5, log to base 4 of 16 equals 2. So I just rewrote that in log form. These are equivalent expressions. One's an exponent and one's a log. So can you take a minute and just complete up through number 7? So we're at the same place. For video's sake, I'm going to unpause. So this would be 10 to what power is 1 over 10,000. So I'm adding 4 zeros, so it'd be the -4th power. And then 3 to what power is 27? The answer is 3. And 4 to what power is 1? So the answer is 0. Anything to the 0 power is 1. So to me, if students can get really comfortable writing from exponent to log form, like this is log base 2 of 1/2 equals -1. So 2 to the -1st power equals 1/2. The base of the exponent is the base of the log. And I think of the exponent and the outside number, they basically change position. So the outside number goes inside the log, and the exponent kind of becomes that outside number. They switch roles. So this would be log base 3 of 81 equals 4. And then this was just kind of showing you how to use the calculator. Common log is written log. It has a base of 10. Natural log, ln, has a base of e. So there's two keys on your calculator that you need to be familiar with. There's a log key and there's a natural log key, ln. So that's not a 1 or an I. It's an L and then N for log natural en français. Anyone take French? So L logarithm and then N natural log. So log natural, ln, stands for a base of E. So these 4 problems, I just want you to type into your calculator. So for example, the log of 8, I type the log button, the number 8, hit enter, I get what, 0.90, rounded to decimal places. Can you try your calculator on 9, 10, and 11? Type either the log or the natural log. This only works for the base of 10 or the base of E. We need another key to change the base. So let's see, the log of 0.2, you should get what, negative 0.70. Natural log of 5, when you type it in, do you get 1.61? And then the natural log of 100, 4.61. Notice that the natural log of 100 and the log of 100 are different because we know the log of 100 is 2. So those have different bases. Let's see, how do I get this to be darker? So it does matter what the base is. You're going to get a different answer based on the different base. So back in the old days when I was in high school, my graphing calculator could only do log and natural log. And so I needed a way to be able to do the log of any base. And so there's something called the change of base formula, which we will see again when we talk about properties. But whatever log you're doing, you're allowed to take the common log and divide by the common log of the base. We now have a button. It's under Math Log Base. So I want you to try this example both ways. So I want you to type in the log of 8, the log of 8 and divide by the log of 4 and just see what you get, 1.5. And then I actually want you to find the log base key. So it's under math and it's at the bottom. It says log base. And I want you to type in that the base is 4 and the number inside the log is 8 and just show that it comes out also to 1.5. So I just use this key usually on my calculator. But this property does exist. So if you're at home and you don't have the graphing calculator, you can use any log button on your calculator. You're dividing by the log of the inside number and you're dividing by the log of the base. And it shouldn't surprise you that 1.5 was the answer, right? 4 to the 3/2 power, square root of 4, and then so the log base 3 of 2 is 0.63. All right, so now here's where it starts to get a little bit tricky. So this is not going to be on your quiz tomorrow, but by your test, you need to be able to figure out how to find inverses algebraically of exponential functions. Remember I said we can't just change addition to subtraction or multiplication division. So exponents, we're going to change to logs, exponents to logs. That's where we are right now. So just tune in when it's new. All right, so we learned that algebraically, you're allowed to switch x and y in a function when you want to find an inverse. So we're going to do the same thing. We're going to switch x and y. All right, so now y is stuck. It is stuck up there in the exponent. I can't get it out unless I change form into log form. So that's why up here, I wanted you to practice going from exponential to log form. So we're going to rewrite this. The base is going to be 6 because the base of the exponent is 6. And then remember I said the stuff that is in the exponent is going to get like unstuck. They're going to switch roles. So basically, I can rewrite this exponential equation as this log equation. So see how it's still a base of 6. I'm raising the 6 to the y power and getting x. So these are equivalent. But what did I just do? I just got y equals as an equation, right? So now y equals log base 6 of x is my inverse function. So logs allowed me to switch x and y and get y out of the exponent. So we're going to do the same thing on 15. Switch x and y. Don't switch anything else. So you're going to rewrite it as x equals 4 to the y plus 1. And I can't switch into log form yet because this plus 1 is sitting here. So my first step is going to be subtract 1 to the other side. So x minus 1 is equal to 4 to the y power. Now I can switch this into log form. So the base of my exponent is 4. That's going to become the base of my log. The stuff that's currently outside is going to go inside the function. And then I've got that is equal to y. So see how when I rewrite this, 4 is the base, raised to the y power, equals the stuff inside the log x minus 1. I'm not going to rewrite it as y equals because I already have y by itself, but you get the idea. You could rewrite this as y equals. And this is really challenging because you're rewriting this kind of abstract equation into a log expression. To me, I think up here, this is easier, rewriting this into an exponential expression when they're numbers and the numbers make sense. These are all just variables, so they don't make that much sense right now. All right, so to switch into an inverse, you switch your x and your y. So I've got x equals 2 to the y minus 3 power. Now, see how all of this stuff is caught up in the exponent? I don't have to move that plus 3 to the other side. Over here, this plus 1 was outside the exponent, so I had to move it to the other side before I could change format. I can change format directly from this step. So my base is going to be 2, x goes inside the log, and y minus 3 gets set free. The whole reason you're doing this is to get the y out of the exponent. So you don't want the y to end up stuck inside the log. There would be no point. So see how this is 2 raised to the y minus 3 power equals x? What would be my last step to get y by itself? So it would be y equals. Add 3. Log base 2 of x with a plus 3 on the outside. And we're going to look at how that changes the graph. Does it shift up, down, left, or right? This shifts it up 3. Just like this one over here in this other equation would shift it to the right by 1. So we're going to see those same transformation rules popping up in our log unit. So this step is not on the test or quiz, tomorrow. The only thing you need to be able to do on the quiz is evaluate logs like we did on the front page. All right, so here is going in a different order, inverses that start out as logs. It's going to be the same thing, but in reverse. So you're going to switch x and y, and you're going to change it into exponential form to get it out of log form. So x equals natural log of y plus 3. All right, all of this stuff is inside the log, so I don't have to subtract 3. I can just switch forms. But to switch forms, I need to know what my base is. So see how there's a base over here on 19? It's 4. What is the base on 18 and what is the base on 17 that they're not writing? Yep, the base on 18 is 10. The base on 17 is actually the constant e. This is log with a base of e. So if I have the base, I'm going to rewrite this as the exponential expression e to the x power equals y plus 3. So the stuff inside the log now gets to go free, and then the stuff that was outside becomes that exponent. So what would be my last step to get y by itself? subtract 3, and the minus 3 is going to be the downshift. It's not going to subtract 3 in the exponent. All right, 2 more on these algebraic inverses, which these are, to me, the algebraic inverse is the most challenging part this unit. So if it seems challenging, it is. So your first step is to switch x and y. It does help you practice inverses though, switching x and y. See how this minus 5 is outside the function? So you actually need to add 5 to the other side before you change form. So I have x plus 5 equals the log base 10 of y. And now I can change form. So 10 is the base, 10 becomes the base of the exponent. The x plus 5 turns into the power, and then you've got y equals left on the other side. So the function is y equals 10 to the x plus 5. Can you try 19 on your own and see if you get to the right ones? And then 20 and 21 I'm omitting from this packet because we haven't learned properties and we're not going to do that one today. But I want to skip down to the graphing before you do a little bit of review for the quiz. And then I think what we'll do is we will keep the guided practice as a warm-up for Wednesday's class because we'll have enough, I think, to maybe I'll have you do the guided practice tomorrow when I'm not here. All right, so you were doing 19, and I'm going to put my answer up in just a second on 19. All right, I'm switching x and y, and I'm rewriting in exponential form 4 to the x equals y minus 1. So y would have to equal 4 to the x with a plus 1 on the outside. Huh? The log inverse, if this is 2 to the x, would be log base 2 of x. So the exponential function and the log of the same base are inverses of each other. So if this was 3 to the x, you'd have to have log base 3 to the x. So you have to compare the same base to each other. And remember, one of our ways to find inverses is to switch x's with y values. So we're going to make a table of values for the exponential function, and then we're going to flip-flop them to do the log graph. So if I take 2 and raise it to the negative second power, I would have 1/4. If I take 2 and raise it to the negative first power, I would have 1/2. Anything to the 0 power I know is 1. 2 to the first power is 2. 2 squared is 4. 2 cubed is 8. So this table is that exponential graph that you've already been tested on. Hopefully you remember it. That's the graph of 2 to the x. Oops. So this is 2 to the x. If I flip those points around, I'm going to do it with a purple pen. I'm going to graph 8, 3, 4, 2, 2, 1, 1, 0, and then these are kind of fractions going this way. So do you see how the purple graph ends up being the inverse of the exponential graph? So that is what a log function looks like. And remember that you can draw in that line of symmetry through the origin, y equals x. So they're symmetrical over the origin. So the key point on the log graph is always going to be its x-intercept, 1, 0. So if you have to move this graph around, that's the point that you're going to be moving around. And guess what happened to the asymptote? Instead of a horizontal asymptote, now I've got a vertical asymptote, right? Remember all the things about x and y flip-flop? So if this was the original asymptote, no, this is the new asymptote. So you can use the exponential function, flipping all the points to find the log function. So we're going to do one more. So let's do base 10 graph. So this time, if I want to do the graph of log base 10 of x, excuse me, I can do the y equals 10 to the x graph. Because those are going to be inverses of each other because they have the same set of points that we're flipping x and y. So let's do it the same way. Let's do our three values. When x is -1, 0, and +1, y will be 1/10, 1, and 10. Right? Those are the key points for this exponential graph. It's going to be really steep because it's a base 10 graph, so I can only fit 3 points on my graph. But if I have 3 points, that's enough to find my inverse. So to do my inverse, I'm just going to flip-flop my x's with my y's. So I'll have 1, 0, 10, 1, 1/10, -1. So it's a really steep sideways curve, and this has a vertical asymptote at 0, so make sure that your arrow doesn't touch. And it's asking you these questions. So it's saying, for the log graph, what would you say the domain and range are for this purple graph over here? Domain would be what? X has to be what for this purple graph? Positive. So x has to be greater than 0. I can never touch it because my asymptote, right, is at x equals 0 for the purple graph. My range is all real numbers, so it's going up and down forever. It's just growing very gradually. The x-intercept is my key point, which is at 1, 0, just like 0, 1 is the key point for the other graph. It's going to be increasing, so as I go to the right, it's slowly going up. It is continuous. I don't lift up my pencil. The inverse function is 10 to the x. So the log graph has that data. All right, so let's just do these last two so we can wrap up graphing. Tomorrow I'm going to have you do some guided practice on this, I think. That or I'll sign it for warm up on Wednesday. I'll have to see how much I'm leaving for you for tomorrow because I don't want to leave too much. The key point for log base 3 of x. And then what is this shift going to do? X minus 1. Right 1. So the log base 3 graph is going to go through 1, 0, 3, 1, because it normally would be 1, 3, right? And then down here at a third. So those 3 points are the parent function for base 3. I'm skipping the exponential one right now because I know if I go over 3, I went up 1. Just like up here, I went over 10, up 1. You're going to go over the base and up 1. So I'm just going to shift all those points right 1, right 1, right 1, right 1. My asymptote also gets shifted right 1. So here's my pencil graph of my base 3 that's been shifted right 1. On number 2, this is a shift that goes up 2 because it's outside the log function. And for the base 4 graph, you start at 1, but this time you go over 4 and up 1. Right? So this is the base 4 log function. And we're just going to shift all those points up 2 units, and then you've graphed the transformation. So it still has an asymptote at x equals 0 this time because I just shifted up 2. And so graphing is not on your quiz tomorrow.